Before you get started with the deployment of Qradar in your infrastructure, you might want to understand the several components it makes use of to function properly. IBM Qradar and the SIEM itself features a modular architecture where you can scale its deployment to add on more devices, endpoints, and machines in your infrastructure to help with your analysis and logging needs. You can also add in modules to help with the analysis, which are easily provided by IBM on the application exchange. The list includes, but is definitely not inclusive to Qradar Vulnerability Manager, Qradar Risk Manager, Qradar Watson Integration, and Qradar Incident Forensics. The Qradar architecture also follows the concept of layering and has three main layers through which the information flows from the endpoints to the agent. Now, mind you, the same architecture is followed in all sorts of deployments, regardless of your organization size, the complexity of your network, or the number of components you're going to utilize. So, how does it all work together? So, IBM Qradar collects, processes, aggregates, correlates, stores, and then finally presents the data from your endpoints in real time. It will use this cleared and clean data to provide you insight and information to help you monitor your IT infrastructure more effectively. This is usually done in the form of alerts, offenses, and responses to threats, which are caught red-handed. Now you can further equip some of the modules we previously discussed to add on more analysis functionalities to your deployment. For example, the incident forensics module can help you break down the steps taken by a malicious actor and quickly draw conclusions based on the artifacts left behind. Now, this can significantly reduce the time taken by your incident response team to conduct the investigation on the offenses logged by Qradar itself. It will also help you resolve breaches, prevent data losses, and attacks from happening again, likely in the near future. If we go back to the concept of layers again, we know that the Qradar architecture is composed of three main layers, right? The first is data collection, the second is data processing, and the final stage is data searches. So data collection constitutes the bottom layer or the first layer of the architecture, and its task is rather simple. It has to collect everything from your network. This includes data such as events, log files, flows, or any other information like scanned data, configuration files, maybe packet captures, and others. You can make use of Qradar event collectors or Qflow collectors to collect this data. Qradar can accept events from several log sources. This includes your firewalls, your intrusion prevention systems, your host-based logging system, or any other valid log source. To collect the data, it makes use of several protocols. The most commonly used protocol is syslog. Other options can also include syslog TCP and SNMP. Qradar can also be set up with outbound connections to retrieve events by using protocols such as SCP, SFTP, FTP, and others. Now, before the data is readily available for your searches and analysis, the data goes through a series of transformations. The first one is parsing. This is where the raw event data is transformed into a more readable and user-friendly format. That's done through the power of DSM editor or the device support model editor. Through the DSM editor, you can quickly transform and parse your data into the format you'd like. However, there's a small prerequisite here that the collection of data has to be via syslog, the protocol, otherwise you can likely not use a parser using the DSM editor. Now after parsing, the normalization process takes over. This involves turning your raw data into a more searchable format, for example, in the concept of fields such as the IP address or maybe usernames. Now this can help Qradar easily create searches and you can further use them. Now we talked about two main types of data before. One was event data and other was flow data. Now let's discuss both of them in detail. So event data is comprised of activities or events which took place on a user's endpoint at a given point of time. This can also be on a different device. It does not have to be a user's endpoint particularly. This could be a firewall configuration change, a network failure, login failures, emails, connections that might have taken place, or any other event that your device had logged. The second type of data is flow data. Flow data is information your network generates upon communication, or perhaps this is the session information from one host to another. These events are transformed into flow records. For example, this raw data of two hosts communicating over a network on a network is transformed into an IP address, ports, bytes, packet counts, protocol, or information that usually summarizes a session's information. One other thing, using the incident forensics module, there's also an ability to carry out a full packet capture, besides gathering flow data, which can actually be quite helpful if you are investigating a breach or a network intrusion. Now, after normalization, Qradar recognizes the event and the log source it's coming from. This is done by extracting relevant information from the IP header. These events are then coalesced into records. But what if Qradar is not able to detect the log source, or maybe it's unknown? The events are then sent off to the traffic analysis engine. This is used for automatic detection of the log source. Now, when new log sources are discovered, a configuration request message is sent off to the Qradar console to add that log source. Qradar console is basically what you have access to. In summary, the event collection layer has the following functions in order. It collects data using known protocols, for example syslog. It monitors incoming events and manages them in queues for throttling. It passes raw events into Qradar usable fields and the ones which you can easily use and search data on. It analyzes the log source by means of DSMs which support automatic discovery. It coalesces all events and on common attributes. It forwards events to other SIEM solutions, targets, or systems. Once the data is parsed and normalized completely on the first layer, it is passed off to the second layer called the processing layer. Here we have event processors and flow processors who are going to process the data that's collected and send it off to the final layer. So what goes on in this layer? The data is first run through the custom rules engine. This is the first step. Here the offenses and alerts are generated based on the data that is received, and this data is written to storage for persistence. Now in the custom rules engine, the custom rules which are created by you, the analyst, or other users on the console are matched against the events which were just parsed. Each rule has particular actions or responses which are set by the user itself. So if the rules conditions match the event, the actions will be taken automatically. That is the job of the CRE. The event processors are also responsible for streaming live data to the console. This is immediately available on the log activity section of the Qradar console. These events are not replayed from the database but are operated on in a live or real-time fashion. However, they are also stored for persistence in the database. There's one other level of abstraction we've left out before, and that is the magistrate. The CREs, or the rule engines, do not pass out matched events directly to the console. They are sent to the magistrate on the Qradar console, which creates and manages offenses on the console. So it has three main tasks. Number one is offense rules. What does the system have to do when an offense has been generated? Number two is offense management. It has to manage the offenses, update the status, and provide more information. Number three is offense storage. Events are later stored in a Postgres-based database once they are completely analyzed. Similarly, the Magistrate Processing Core, or the MPC, is responsible for correlating offenses with event notifications from multiple event processor components. That is the main task of the data processing layer. Now finally, the normalized and processed data is sent to the final layer on Qradar. This is where the data is searchable by users or you as an analyst. It can help you analyze, report, and investigate on alerts which are generated by the previous two layers on Qradar. The Qradar console also allows analysts to take investigative actions and perform administrative tasks. Now, in a distributed environment, the Qradar console does not perform event all flow processing and or even storage for that matter. It is simply used as a user interface where the users can come in for searches, reports, alerts, or investigations. Now that's it for today, folks. This is the general architecture of IBM Qradar as a SIEM, and we are going to likely discuss more such topics on Qradar in future videos. Thank you.